Hello students, let us start with the next module of this chapter, probability distribution, and here we are going to learn problems on PDF and CDF. So the first question goes like this: find CDF, that is capital F of x, and with the following PDF, that is small f of x, 1 upon x square, where x is greater than 1 and less than infinity. Also sketch f of x and capital F of x, that is we have to sketch the graph of PDF and CDF as well. So moving with the solution here, f of x, that is CDF, is given by integral lower limit to xi f of x dx. So here I can write f of x is equal to integral 1 to x f of x dx, which is simply equal to integral 1 upon x square dx from 1 to x. So here I can write the value of integral 1 upon x square as minus 1 upon x from the limit 1 to x. And on substituting the limits, or here what we can do is we can take out the negative sign. So I can write it as 1 upon x from x to 1. So when we remove negative sign, the limits get interchanged. So here applying the limits, we will get it as 1 upon 1 minus 1 upon x. So this value will be simply equal to 1 minus 1 upon x. This is the value for f of x, that is CDF. Moving further, graph of f of x. F of x is nothing but 1 upon x square, where x is greater than 1 and less than infinity. So when x is equal to 1, we have f of x as 1 upon 1 square, which is simply 1. So here the graph is as follows. We will have the x-axis and y-axis. Y-axis will be the value for f of x. So for 1 it is 1. So you can see the red point there. Now when x is equal to 2, we have f of x equal to 1 upon 2 square, which is 1 upon 4, which is 0.25. So the second point will be here as shown. For x equal to 5, it is 1 upon 5 square, that is 1 upon 25, which is 0.04. So the point can be plotted here on this part. Now when x is equal to 10, we have f of x equal to 1 upon 10 square, that is 0.01. So this point can be plotted here. Now when I connect all these points, I get a graph which is a curve tending towards 0, that is tending towards the x-axis. So this is the graph for f of x. Now here I have taken only those values of x for which I can calculate f of x. Now moving further, here sketch of capital F of x, that is CDF of f of x. F of x was equal to 1 minus 1 upon x. So here we have to take values of x. So when x is 1, f of x will be equal to 0. So the graph is as follows. Now here if you observe, I have drawn a line parallel to x-axis. Here it states that f of x can maximum go up to 1. The graph should not go above this line here. So when x is 1, I have f of x as 0. So this is the required point. Now I take x equal to 2. So f of x will be 1 minus 1 by 2, which is equal to 0.5. So here it will be. Now for x equal to 5, f of x will be equal to 1 minus 1 by 5. 1 by 5 is nothing but 0.2. So 1 minus 0.2 will be 0.8. So here I will be plotting the another point, 0.8. Now when I join all these points, I get this following curve. It is the graph for CDF of f of x. Now here we have completed this question. And for the last part, when f of x equal to infinity, f of x will be equal to 1. So this graph goes to 1 when x is equal to infinity. Moving further, here the next question is as follows. X is amount of time for which book is taken out of a college. F of x is given to be us as 0.5x, where x is greater than equal to 0 and less than equal to 2. We have to calculate the following values. The solution goes like this. For the first part, p of x less than equal to 1, here we will simply take integral 0 to 1 f of x dx. So integral 0 to 1 f of x dx will be equal to integral 0 to 1 0.5x. Now here I can write it as integral 0 to 1 x by 2 dx. So integral x raised to n dx is nothing but x raised to n plus 1 upon n plus 1. So here this value will be 1 by 2 is a constant taken outside, and integral x dx will be x square upon 2 from 0 to 1. Now applying the limits, I get the value as 1 upon 4. So this is the value for p of x less than equal to 1. Moving further to the next part, we have been asked to find out p of x greater than equal to 0.5 and less than equal to 1.5. P of x greater than equal to alpha less than equal to beta will be simply equal to integral alpha to beta f of x dx. So I can write it as integral 0.5 to 1.5 f of x dx, and we have the value for f of x dx as x by 2 dx. So substituting the value here, integral x raised to n dx is x raised to n plus 1 upon n plus 1. So here the terms will be 1 by 2 into x square upon 2 from the limit half to 3 by 2. Here half is nothing but 0.5 and 3 by 2 is nothing but 1.5. So substituting the limits, I get the value as 1 by 4 into 9 by 4 minus 1 by 4. So this value is nothing but 1 by 2. So this is my value for p of x greater than equal to 0.5 and less than equal to 1.5. Now moving further to the third part here. The third part, we have been asked to find out p of x greater than 1.5. So friends, x greater than 1.5 means x can go up to 2 only. So here integral, we have to find probability of x greater than 1.5 and less than 2. So I can write it as integral 1.5 to 2, 0.5x dx. Integral here, it will be from alpha to beta f of x dx using this relation. So integral x raised to n dx is simply equal to x raised to n plus 1 upon n plus 1. So substituting the values, I will get it as 1 upon 2 into x square upon 2 from 3 by 2 to 2, where 3 by 2 is nothing but 1.5. On solving this further, I get the value as 1 upon 4 into 4 minus 9 upon 4. So this value will be simply equal to 1 by 4 into 16 minus 9 by 4. So on further calculation, I get the value as 7 upon 16. So this is the probability for p of x greater than 1.5, which turns out to be as 0.4375. Thank you.